So welcome back to another video. So for today, let us have elimination of arbitrary constants in differential equation. So the first example is eliminate the arbitrary constants C1 and C2 from the relation y is equivalent to C1 e raised to negative 3x and plus C2 e raised to 2x. So we are asked to eliminate the constants C1 and C2. So in this problem, we will have first the derivative of this equation, the first and second derivative, and see what we can eliminate. So first, let us have the first derivative of this equation. So let us assign that this relation will be the first equation. This one will be equation 1. So let's have the first step for the solution. So first one is getting the first derivative. So let us recall that that e raised to u is equivalent to derivative of e raised to u is equivalent to eu du. Okay, so let's use that. So y prime is equivalent to, since c1 is constant, let us first um set c1 aside. So that one will be c1 multiplied to uh, e raised to negative 3x, derivative of negative 3x is negative 3, plus c2, derivative of e to the 2x is multiplied to e raised to 2x times 2. Okay? So rewriting this equation will yield, so y prime is equivalent to negative 3c1 e raised to negative 3x plus 2c2 e raised to 2x. So this one will be your equation 2. So how about the second derivative? Uh, Let me rewrite this first and second derivative. So commonly in this type of equation, since we have two constants, so commonly we need to obtain also the second derivative here. So let's have the second derivative. So that one will be y double prime equivalent to the derivative of this equation. This first, then the other one. Okay, so that one will be uh positive. Oops, wrong color of pen. So that one will be positive 9c1 e raised to negative 3x plus 4c2 e raised to 2x. Okay, so that one will be your equation 3. So now we will proceed with step 2, eliminating constants. By using the first two equations, equation 1 and equation 2. So equation 1 is the given, which is y is equivalent to c1 e raised to negative 3x plus c2 e to the 2x. Then equation 2 will be the y prime or the first derivative, which is equivalent to negative 3c1 e raised to negative 3x plus 2C2 e raised to 2x. So let me first eliminate C1. So I will multiply here. To eliminate C1, I will multiply here 3 to cancel C1. So simplifying this equation will be, uh, that one will be 3y equivalent to 3c1 e raised to negative 3x plus 3c2 e raised to 2x. So y prime, then copy this equation. Y prime is equivalent to negative 3c1 e raised to negative 3x plus 2c2 e raised to 2x. So after that, let's simplify these equations. So this one will be cancelled out. So let's simplify. So that one will be 3y plus 3y plus y prime is equivalent to 3 plus 2 is 5c2 e raised to 2x. Okay, so this one will be your equation 4. Okay, then after that, let us proceed with step 3, eliminating constants. Eliminating constants for equation 2 and 3. Okay, for equation 2 and 3. Okay, so let us eliminate constants for equation 2 and equation 3. So let me rewrite the equation for equation 2. Equation 2 is the first derivative, which is y prime. That one will be y prime equivalent to negative 3c1 e raised to negative 3x plus 2c2 e raised to 2x. So the third equation is y double prime equivalent to 9c1 e to the negative 3x, then plus 4c2 e to the 2x. So let's see what we can do to eliminate. So I will eliminate here again C1. So constant 1 first. I think we can multiply this to positive 3. Let's multiply it to positive 3 and simplify. So simplifying, that one will be distributing 3 to the inside term. So that one will be 3y prime equivalent to negative 9c1 e raised to negative 3x plus 6c2 e to the 2x. And then copy the other equation y double prime equivalent to 9c1 e raised to negative 3x plus 4c2 e raised to 2x. So let's simplify. So this one will be cancelled out. Therefore, what's left is 3y prime plus y double prime equivalent to 10c2 e raised to 2x. So this one will be your equation 5. So again, let us eliminate constants by using equation 4 and equation 5. So I will use the space here. So this one will be your final step. Step 4. Step 4 is eliminating constants using uh, equation 4 and equation 5. Okay, so let us eliminate constants for equation 4 and equation 5. So that one will be this one. So let me copy here first and move it upward. So 3y plus y prime is equivalent to 5c2 e raised to 2x. And the other one is 3y plus y prime equivalent, y double prime, sorry, y double prime equivalent to 10c2 e raised to 2x. So let me drag this to this one. Okay, so let's see what we can eliminate here. So I think we can multiply this equation to 2 to eliminate the constant. To negative 2 rather, to negative 2. Okay? So simplifying, we have uh negative 6y plus minus 2y prime equivalent to 10c2, negative 10c2. Do not forget the sign. So negative 10c2 e raised to 2x. Then let's copy here 3y minus y double prime equivalent to 10c2 e raised to 2x. So the constants here will be cancelled. So what's left is negative 6y minus 2y prime. Wait, I think something's wrong. So this one is 3y prime, I think. If I'm not mistaken, 3y prime. Yes, 3y prime plus 3y prime minus y double prime is equivalent to 0. So let us simplify like term. So that one will be negative 6y, negative 6y plus y prime minus y double prime equal to 0. So this one will be your answer. However, we can simplify this by arranging y double prime plus y prime minus 6y equivalent to 0. So multiplying both sides by positive 1, by negative 1 rather. So that one will yield y double prime minus y prime plus 6y equivalent to 0. So this one will be your answer. Okay? So that is will be the solution for question 1 by eliminating constants C1 and C2. Okay? So let's have the next question. So the next question is this one. So second example, we have uh, x cubed minus 3x squared y equivalent to C. Okay? So let's have the first derivative of this equation. So let's have the first derivative of this equation to eliminate the constant. So first, let's have the derivative of 3 x cubed. So getting the first derivative. So getting the first derivative of this equation, that one will be 3x squared d of x minus this one is, since we have 3x squared and y, so this one will be u and this one will be v. So by using the product rule, so that one will be u dv plus v du. Okay? So u dv plus v du. That one will be, okay. So u dv, so u here is negative 3x squared, dv will be the derivative of y. So that one will be 3x squared dy minus, let's copy v, then the derivative of u is, here will be 6x 6x, okay? So 6x. So 6x dx, okay? 6x dx, then the derivative of a constant is 0. So let me rewrite the equation. So that will be 3x squared dx plus, minus 3x squared dy minus 6xy dx equivalent to 0. Okay, so we can simplify here 3, uh, since we have all a common ground here, so we can divide all sides, both sides rather, we can divide both sides by what? By 1 over 3x. So that one will be here 1 over 3x. Okay? So the equation will then be like this. So dividing both sides by 3x, so it will yield x dx. X dx, this one will be negative um, x dy. Then the other one here will be negative 2y. Wait. 2xy, rather, 2xy. No. 2y dx only. 2y dx because x will be eliminated already. Okay? So equivalent to 0. So after this, we can group the terms. So like terms, we can group the terms. So that will be x dx minus 2y dx minus x dy equals 0. So let us simplify further. So x minus 2y, by grouping the terms, like terms, dx minus x dy is equal to 0. So this one will be your final answer. Okay? Next, let's have this one. So um this one is y sine x minus xy squared. So we need to get also the first derivative here. So the solution is getting first derivative. So by getting the first derivative of this equation by using the product rule again, so that one will be u dv plus v du. So that one will be the derivative for this one since it is a product. Okay, so let us assign u and v. So this one will be u, this one will be v, this one will be u, this one will be v. Okay, so let's have it. So let's obtain the first derivative. So first, let's copy that is y. Then the derivative of sine x is cosine of x dx. Y cosine x dx. Then the other one plus v, let's copy sine x. Then the derivative of y is dy, sine x dy, minus, let's have it, the derivative of this equation. So xy squared will be, first let's copy u. So u is x. The derivative of v is 2y dy. 2y dy plus v du, y squared d of x. So this one will be your derivative here, equivalent to 0. Okay, so let's multiply negative to the inside. So that one will be y cosine x dx plus sine x dy minus 2xy dy minus y squared dx equal to 0. So let's group like terms. So that one will be uh, y cosine x dx minus y squared dx plus sine x dy minus 2xy dy equals 0. So let's simplify further what we can do. So um I think we can move cosine x, no? So let me rewrite this into a more proper way. So this one will be cosine xy dx. And this one will also be cosine xy dx. Okay. So uh, since the equations are now grouped, then we can simplify further. Um, we can have y here and on the outside, y on the outside, then cosine x on the inside minus y, then this one will be dx. Plus, we can have, hmm, we can have it like this way. So this one will be sine of x minus 2xy dy equal to 0. So this one will be your final answer. Okay? So that will be your final answer for question 3. Next, let's have the fourth question, which is this one. So in this question, we are asked to eliminate the constant. We have the constant here. So let's have the solution. The solution here is to get the first derivative first. So by getting the first derivative of this equation, it will yield. So using the product rule and this one will yield this solution. UdV plus BdU. So let us recall that UdV plus VdU. Okay? So UdV plus BdU. So this one will be the U is x squared. Oops, wrong pen. So x squared. The derivative of y is dy, x squared dy plus y multiplied to 2x d of x. Equivalent to the derivative of 1 is 0 plus u dv is c. Derivative of v is dx, c dx plus v du. V is x plus the derivative of a constant is 0. Okay, so let us simplify. So that one will be x squared dy plus 2xy dx equivalent to c dx. Okay, so we can multiply both sides by dx, by 1 over dx rather. 1 over dx, 1 over dx. So let's multiply it. So that one will be x squared dy, dy over dx, sorry. Dy over dx. Oops. Plus, this one will be 2xy only equivalent to c. Okay, so this one will be your c. We can substitute c to the original equation. So let us substitute c to the original equation. That one will be your second step. Substitute c to original equation. Okay, so let's substitute c to the original equation. That one will be um, x squared y, x squared y equals 1 plus c. What is c? C is x squared dy all over dx plus 2xy multiplied to x. So let's distribute x. So that one will be x squared y equals 1 plus x cubed dy over dx plus 2x squared y. Okay, so we can multiply both sides by dx to eliminate dx. So multiply both sides by dx. So this one will be, distributing uh, x squared y, x squared y dx equivalent to dx plus x cube dy, ay sorry, x cube dy, x cube dy plus 2x squared y dx. Okay? So let's further simplify the equations. So this one will be um, x squared. So transposing the equations x squared y dx minus dx minus 2x squared y dx minus x cubed dy equal to 0. So let's see what we can simplify here. This one will be, hmm, so we can simplify like terms here. So this one and this one can be simplified. So if we will simplify that, it will yield negative x squared y dx minus dx minus x cubed dy equal to 0. So we can multiply both sides by negative 1. So the answer here will have x squared y dx plus dx plus x cubed dy equal to 0. So we can simplify this further by this format. So this one will be x squared y plus 1 dx plus x cubed dy equals 0. So this one will be your final answer. Okay, so this one will be your answer here. Next, the fifth question is, huh? The fifth question is this part. So, first, we have to get the solution for first derivative. So for the first derivative of this equation, it will yield, since this is also u, v, then we can clearly say that the first derivative for this one is u dv, so that one will be c. U dv is, derivative of b is 2y dy plus y squared. Then the derivative for constant is 0, equivalent to 2x dx plus dy. Okay, so 2x dx plus dy. This one will be your derivative. This one will be cancelled out because it will be yield just 0. So simplifying, so that one will yield 2cy dy equivalent to 2x dx plus dy. So multiplying both sides by 1 over 2y dy. So simplifying the equation will yield c is equivalent to uh, 2x dx all over 2y dy plus 1 over 2y. So this one will be the equation. Let's cancel out 2 here. So this one will be 1 and 1. So simplifying further the equation, it will yield this answer. So x dx all over y dy plus 1 over 2y. Okay? So this one will be your C. Then, substituting to the original equation, our original equation is cy squared. Sub Substituting C to original equation. So that one will be c squared equals to cy squared, sorry, is equivalent to x squared plus y. So this one, if we substitute, it will yield this. X dx all over y dy plus 1 over 2y multiplied to y squared equals x squared plus y. Distributing y squared, so that one will be xy squared d of x all over y dy plus y squared all over 2y. So canceling out common terms, like terms. So this one will be cancelled out and this one as well. So this one will yield just y. This one will be 1. This one will be 1 and this one will be y. So rewriting the equation, it will be xy dx all over dy plus 1 half y equivalent to x squared plus y. So multiplying both sides by, we can multiply both sides by 1 over dy. By dy only, to eliminate dy. So let's multiply both sides by dy. So that one will have this equation. So x y dx plus 1 half dy, y dy, sorry, y dy equivalent to x squared dy plus y dy. Then we can multiply also both sides by 2. So that one will yield an answer of 2xy dx plus y dy equivalent to 2x squared dy plus 2y dy. So transposing the term, so that one will have 2xy dx plus y dy minus 2x squared dy minus 2y dy equal to 0. So simplifying like terms like this one and this one will yield 2xy dx minus 2x squared dy minus y dy equals 0. So this one will have this answer 2xy dx simplifying further. Then this one will have um, negative x squared minus y plus y dy equal to 0. Wait, I forgot to here. Okay, let me rewrite. So this one will be 2x squared minus y dy equal to 0. So this one will be your final answer. Next, okay. So in this equation, A is the constant, okay? So A is the constant here. Uh, this one will be U and this one will be V, okay? So we can use that. So let's have the first derivative. So getting the first derivative of this equation will yield uh, 2y dy is equivalent to udv, so 4a multiplied to dx plus x, derivative of a constant is 0. So therefore, this one will be cancelled. And then the equation will be 2y dy equivalent to 4a dx. Dividing both sides by 1 over 4 dx. Therefore, the equation will be 2y dy over 4 dx equivalent to a. Okay, so let's simplify. So this one will be 1, this one will be 2. So therefore, so therefore, um, the equation will be um, 1 half dy, wait, let me rewrite, uh, y dy over 2 dx is equivalent to a. So let's substitute, substituting sabing a to original equation. So sabing A to original equation, what is the original equation? That is y squared is equivalent to 4ax. So y squared is equivalent to 4 multiplied to y dy over 2dx, then this one will be x. So distributing, that one will be y squared is equivalent to 4y dy, 4xy, sorry, 4xy dy over 2dx. So simplifying further, we can simplify this by multiplying 2d by cross multiplying. So this one will yield 2 2y squared dx equivalent to 4xy dy. Then this one will be 2y squared dx minus 4xy 4xy dy equal to 0. So we can divide both sides by 2y. So we can divide both sides by 2y. So this one will be 1 over 2y. So simplifying further the equation, it will yield this one. So 2y divide y, 2y squared divide 2y will be uh, y dx, I think, y dx. So this one will be cancelled out. So this one will be just y. Okay? And this one will also be cancelled. 1. This one will be 2. This one will be 1. So rewriting the equation, it will yield this equation y dx minus 2x dy equal to 0. So this one will be your final answer. Okay? So this one will be your final answer for this problem. So next, let's have this one. So y is equivalent to c1 plus c2 e to the 3x. So this one is similar to the problem that we have before. So first is we will get the first derivative. So getting the first derivative, this one will be y prime is equivalent to derivative of the constant is 0 plus derivative of e raised to 3x is uh, 3c2 3c2 e raised to 3x. Then next we will have the second derivative. Second derivative. So what will be the second derivative of this equation? So that one will be y double prime is equivalent to 9c2 e raised to 3x. Okay? So since we have both of the equations, so now um we can now eliminate the constant. So this one will be your equation 1. And this one will be your equation 2. So let's cancel 0 here. Let us rewrite both of the equations so we can see what we can eliminate. This one will be y prime is equivalent to 3c2 e raised to 3x, then the other one is y double prime equivalent to 9c2 e raised to 3x. So let's multiply the first equation by negative 3. Okay? So this one will be, let's simplify. So this one will be negative 3y prime equivalent to negative 9c2 e raised to 3x all over y double prime equivalent to 9c2 e raised to 3x. So the constants will be cancelled. So therefore, we are now left with this final answer. So that one will be, oops, so that one will be negative 3y prime plus y double prime is equivalent to 0. So this one will be your equation. Okay? And then let's have the another example. So this example, we will use WSA parameter. So we'll use WSA parameter. So let's have the first derivative of this equation. Then we have constants C1 and C2 as well. Okay? So we have constants C1 and C2 as well. So let us have the derivative for this equation. So dx all over dt is equivalent to the derivative of this one is C1 since constant C1 multiplied to let's recall the derivative for cosine is uh, cosine u. Cosine u is equivalent to negative sine u du. And sine u is equivalent to positive cosine u du. Okay, so this one will be your derivatives for the both of cosine and sine. So let's derivative cosine wt. So that one will be negative sine wt multiplied to w. Because the derivative of wt is w. Okay, then plus that this one will be, let me erase this already, so that's just a review, plus C2 multiplied to cosine WT multiplied to W. So this one, let's simplify. This one will be your first equation or your first derivative. Dx over dt is equivalent to C1, wait. C1 negative W sine WT plus C2 W cosine WT. Okay, so this one will be your first derivative. How about the second derivative? So getting the second derivative of this equation, this one will yield. So this one will yield this equation. So d squared of x all over dt squared, which is the second derivative, is equivalent to uh, let's use here the product rule, no? So this one will u is u, this one is v. So this u, this one is v. So let's try. Uh, okay. So let's try. This one is C1 UDV plus BDU. So u is C1 v, derivative of v is this one. So derivative of this one is Um, hmm, what is the derivative of this one? This one is negative w multiplied to cosine wt. So this one will be the derivative of v. How about v du? So v du is negative w sine wt times 0. Derivative of constant is 0, so this one will be cancelled out. Let me have here a parenthesis. Oops, wrong. Then, let's have this one. The derivative of this one will be C2 plus C2 multiply to the derivative of V is W times negative W sine omega t plus W cosine omega t or wt times 0. So derivative of constant 2 is 0. So this one will be also cancelled out. So let me rewrite the second derivative. So that one will be d squared of x all over dt squared equal to negative c1 w squared cosine. Sorry, I forgot here the W, no? If we will derivative this one will be negative W multiplied the W cosine WT. Okay, so that one will be W squared, the W squared cosine WT. So this one will be plus 0. So cancelled out na yan. Then this one will be minus. Sorry, not plus, minus, because we have the negative sign. So W times W, negative W times W is W squared. So W squared, wait, I forgot the constant, C2. So C2 W squared sine WT. Okay, so this one will be your second derivative. As we all know, this equation uh, we will recall the equation above wherein x is equivalent to C1 cosine WT plus C2 sine WT. So we can factor out W squared. So factoring out W squared, so that one will be d squared of x all over dt squared equivalent to uh, negative W squared multiplied to C1 cosine WT plus C2 sine WT. So this one is equivalent to X. Equivalent yan sa X. Okay? So substituting X, so sabing X, that one will yield this answer. Uh, d squared of X over dt squared is equivalent to negative W squared of X. Or simplifying this, it will yield d squared of X transposing this one to the other part, to the left hand side. It will yield this answer. So d squared of X dt squared is equivalent to is uh will this one will be positive W squared of X equivalent to 0. So this one will be your answer. Oops. Okay. This one will be your answer for this question. Next, let's have this one. So y is equivalent to cx plus c plus 1. So let's have the first derivative. So the first derivative of this equation will be y prime is equivalent to, this one is u v. So v du, u dv pala, sorry. So u dv, oops, wrong pen. So u dv, oops, u is c dx, hmm, okay. So this one will be c derivative of x is 1 times plus uh, x multiplied to 0 because the derivative of a constant is 0 plus 0, derivative of c plus 0. So therefore, we can conclude that y prime is equivalent to c. Okay, so we can substitute c to y prime to, let's substitute c to the original equation. So let's substitute. So what is the original equation? The original equation is uh, y equals cx plus c plus 1. Wait, this one is c squared. I think c squared. Oh no. This one is c squared. Ay, c squared. So let's substitute it. So this one will be um this one will be y is equivalent to y prime of x plus y prime squared plus 1. So this one will be your final answer. So let's have the 10th problem. So y is equivalent to a e to the 2x plus b of x e raised to 2x. So in this problem, we also have two constants a and b. So therefore, we will obtain both of the first and second derivative as well. So let's first have the first derivative. So let's have the first derivative of this uh, problem. So getting the first derivative, we have y prime is equivalent to, since a is constant, let us set aside a, and that will be a multiplied to e raised to 2x. Derivative of e raised to u is eu du. So derivative of 2x is 2. Okay? Then plus b, set aside the constant, so that one will be b multiplied to, this one will be u and v. So let's use recall the product rule u dv plus v du. So therefore, the derivative here will be x derivative of v is e to the 2x multiplied to 2. So that one will be 2a raised to 2x plus v multiplied to the derivative of u, which is x, uh, multiplied to 1. So simplifying this one will be y prime is equivalent to 2a e raised to 2x plus uh, b multiplied to 2 2x e raised to 2x plus e raised to 2x. Okay? Then simplifying further, y prime is equivalent to 2a e raised to 2x plus 2b e raised to 2x plus be raised to 2x. Okay? So this one will be your second equation. So let this one be the first equation, equation 1. So this one will be your equation 1. This one will be your equation 1. And the other one will be your equation 2. This one, equation 2. Then next will have the second derivative. So the second derivative will be, y double prime is equivalent to, this one will be a multiplied to 4 multiplied to 2e raised to 2x 2a raised to 2x multiplied to 4. So that one will be the derivative of this one. Next will be the derivative of this one. So we also have here the product rule. So uv. Therefore, this one is plus 2b. Let me set aside the constants. So the derivative of x e raised to 2x is x multiplied to the derivative of e raised to 2x is 2e raised to 2x plus the derivative of vdu udv plus vdu. So v, let me copy v. So that one will be e raised to 2x multiplied to the derivative of x is 1. Okay? Then plus 2b e raised to 2x. That one will be the derivative of this uh, part. Then after that, let's simplify. Let's distribute. Y double prime is equivalent to 2a, 4a rather. Wait. This one will be not be 4 but 2. Okay, so that one was my mistake because a raised to 2x is the derivative of this one is 2a raised to 2x. So multiplied to 2. 2a raised to 2x multiplied to 2. I think it's best to set aside 2 here so that it will not cause confusion. So let me rewrite this into 2a. So this one will be 2a e raised to 2x multiplied to 2. So therefore, let us distribute. Therefore, this will be 4a e raised to 2x plus distributing this one to this one as well. It will be 4b 4b x e raised to 2x plus 2b e raised to 2x plus 2b e raised to 2x. So let's combine like terms, combining these terms. So it will be y double prime is equivalent to 4ae raised to 2x plus 4b x e raised to 2x plus 4b e raised to 2x. So this one will be your equation 3. So after getting all the equations, so let's first have elimination of constants by using equation 1 and equation 2. Okay? So first let's have equation 1 and equation 2. Okay? So let's first have the equation 1. So what is the equation 1? The original equation is y is equivalent to ae 2x plus b bx bx e raised to 2x. Then the second equation is y prime is equivalent to uh, 2ae raised to 2x plus 2b xe raised to 2x plus be raised to 2x. So let's see if that one is the equation. So okay, correct. So let's see what we can uh, eliminate. So let's try to multiply the first equation by -2 to eliminate constants. So this one, simplifying, it will yield uh, -2y, -2y equivalent to ae 2x plus bx e raised to 2x. Then the other one, let's copy. So that one will be y prime equivalent to 2ae raised to 2x plus 2b. Wait, I forgot to distribute -2. So first, let's distribute -2. So that one will be -2a e raised to 2x plus 2b minus 2b, sorry, minus 2b x e raised to 2x. Then this one will be y prime equivalent to 2a e raised to 2x plus 2b x e raised to 2x plus be to the 2x. So we can see that we can cancel this one, this one, this one, and this one. So we're just left with that one will be negative 2y plus y prime is equivalent to be raised to 2x. Okay? So since we eliminated the uh, equation 1 and equation 2, so let's try to eliminate some constants with equation 2 and equation 3. So this one will be your equation 4. That will later then be used to eliminate another constant. So let's try to eliminate constants. So elimination of constants, equation 2 and equation 3. Okay, so the elimination of constants for equation 2 and equation 3 will be what? So let's first copy equation 2. Equation 2 is the first derivative, which is y prime is equivalent to 2ae raised to 2x plus 2b x x e raised to 2x plus be raised to 2x. Then y double prime is the other equation, equation 3. Y double prime is 4ae raised to 2x plus 4b x e raised to 2x plus 4b e raised to 2x. So we can simply multiply equation 2 by negative 4. So let's simplify. This one will yield negative 4y prime equals to, wait. Negative 2. Negative 2 rather, not negative 4. Negative 2 only. So sobra kasi. So negative 2. So this one will yield this answer. So that one will be negative 2y prime. Negative 2y prime is equivalent to negative 4ae raised to 2x. Negative 4b xe raised to 2x. Negative minus 2 b e 2x. Then let's copy the other equation, y double prime equivalent to 4ae raised to 2x plus 4bxe raised to 2x plus 4b e raised to 2x. So let's simplify. This one will yield an answer of, this one will be cancelled, and cancelled. So this one will yield negative 2y prime plus y double prime is equivalent to negative, is equivalent to 2b e raised to 2x. So this one will be your equation 5. So next, let us eliminate the arbitrary constants for equation 4 and equation 5. So we're just left with constant b. Okay, so let's move in here. So the last step is elimination of constants. Elimination of constants for equation 4 and equation 5. So elimination of constants for equation 4 and equation 5. So let's have it. Let's copy the equations, both of the equations. So isulat ko muna dito. So that one will be negative 2y plus y prime equals b e raised to 2x. Then the other one is negative 2y prime plus y double prime is equivalent to 2b e raised to 2x. So let's select this and let's move on here. Hey, so we can clearly see that we can eliminate b constant b here by multiplying the above equation um to negative 2. So let's simplify. This one will yield um negative 4y minus 2y prime equivalent to 2 negative 2b e raised to 2x. Then let's copy the other equation. 2y prime plus y double prime is equivalent to 2b e raised to 2x. So simplifying this will yield, this one will be cancelled out. So this one will be cancelled out, will be equivalent to 0. So let's try it, adding all of the remaining equations. So 4y minus 2y prime plus 2y prime plus y double prime is equivalent to 0. Therefore, our answer here will be um hmm, 4y prime, y double prime 2y prime, 2y prime. Mhm. Mm. Sorry, I think I have a wrong solution. So this one will be positive 4y. Positive 4y, positive 4, because negative 2 times negative 2 is positive 2. Okay? So 2y prime minus 2y prime. Whoops. Okay. So the signs here as well is wrong. So this one will be negative 2y prime. Okay. So this one will be negative 2y prime, negative 2y prime. So let's have the answer here will be 4y minus 4y prime plus y double prime is equivalent to 0. So let me arrange. So this one will be y double prime minus 4y prime plus 4y is equivalent to 0. So this one will be your answer here. So that's a long solution we have for this problem. Long solution we have for this problem. Okay, so that's it for elimination of arbitrary constants. I hope you obtained something. So please do like, share, and subscribe this video if you found this video helpful. Okay, so and see you on the next ones.